Lesson 2.1, Conditional Statements. So conditional statements, first vocab word, a logical statement that has something called a hypothesis P and a conclusion Q. So oftentimes they'll actually tell you the P and the Q. Everything that we are doing here are conditional, based off of conditional statements. So the first one that's we use maybe a little bit more is an if-then form. Usually when we have a conditional statement, we put it in the if-then form. And that's when it goes, if P, then Q. So if it rains, then I will go to the park. If I do my homework, then I can watch TV. If I study for a test, then I will get an A. You'll see the if and you'll see the then. Occasionally in English, we leave off the then. Say, if I study, I'll get an A. So the then is not always there, but it usually is, especially just for the simplicity of high school logic here. So if P, then Q. The first part, the P, is the hypothesis. The Q is the conclusion, just as we stated up here. Sometimes it may also be written if A, then B. Now, whether you use P and Q or A and B, it's just up to you. It's up to whatever teacher happens to be teaching it, whoever happens to be writing the book. The negation is the opposite of the original statement. We write not P. That's called a tilde, and it's the word not. So let's say P was something like, it rains. Not P is the negation of it, the opposite. So it doesn't rain. Now be careful with opposites. The opposite of on is off. The opposite of up, we're taught, is down, but not up is different than down, because it could also be the same. Maybe it didn't go up, it didn't go down, it stayed the same. So it's usually best to just put doesn't or not or no or some word to negate the statement. So instead of it rains, put it doesn't rain. Now the converse is where you exchange the hypothesis and the conclusion. So instead of if P then Q, the converse is if Q then P. You switch the two phrases, the P and the Q. The inverse. So we had converse, now we have inverse. The inverse is where you negate the hypothesis and the conclusion of the conditional, of the original if then, which is if P then Q. So you negate both. It's if not P, then not Q. If not P, then not Q. Now, equivalent statements are statements that are both true or both false. If you have two different phrases that happen to both be true, then we call them equivalent. The next important word, though, is contrapositive. This is where you switch. And you do both, the converse and the inverse. So for the converse, instead of PQ, we went QP. For the inverse, instead of PQ, we went not P, not Q. We put the nots in there. For the contrapositive, we need to do both. We switch the order and negate. If not Q, then not P. So how do you keep the converse, the inverse, and the contrapositive figured out? So for me, contrapositive, that's the biggest word. That's a word that is, 5 syllables long? It's the biggest, longest word to write. It's the one that requires the most work down here. You have to switch the order and you have to put the negations. The inverse is where you put in the word that starts with an N, not. So you're putting in the nots. If you want to take it one step further, that little symbol there kind of looks like a lowercase n. So you're putting in the symbols with the inverse. The converse is where it's the other one for me. I remember the contrapositive, I remember the inverse, the converse is just the third one. Perpendicular lines. Perpendicular lines are lines that cross to form a right angle. Most intersections are perpendicular. You can put the little 90-degree symbol right there. A biconditional. The biconditional is used when the converse, if Q then P, and the conditional, if P then Q, are both true. If you can go forward or backward, if P then Q, if Q then P, the faster way to write it is with a biconditional. Bi means it's going both directions. And what you write is P, if and only if Q. If you prefer, you could put Q if and only if P. You don't do it both ways. It's taking the two separate sentences, if P then Q, if Q then P, and it's putting it into one sentence, P if and only if Q. Notice it has two ifs instead of one, and there is no then. This is not an if and only if statement. You put if and only if between the P and the Q. Truth tables and truth value we will not do. So example 1. Let P be an animal as a puppy and Q be it as a dog. Write each statement in words, then decide whether it is true or false. So first, the conditional statement P arrow Q. So the symbol right here, this is logic-based symbols. So let's go back to the front and write the symbols down. Some people, if P then Q, that's too much. They want to make it even faster to write. So they can write P arrow Q. This notation here is read if P then Q. So what about this one? If Q then P. You can actually write it Q arrow P as a faster notation. If tilde P then tilde Q. If not P then not Q for the inverse. That can be written tilde P arrow tilde Q. And if and only if is P with a double arrow Q. So let's go back here. The conditional statement. This is asking you to say that if P then Q. So, if, what's P? An animal is a puppy. So if the animal is a puppy, then, see comma, there's a comma there, then Q, it is a dog. Let's do the converse. The converse, that was when we switched the order, Q, arrow P. So this is where the Q comes first and then the P. So if it is a dog, then the animal is a puppy. So the first one, if the animal is a puppy, then it's a dog. The second one, if it is a dog, then the animal is a puppy. The third one, the inverse, that's where it's tilde P, arrow tilde Q. You're throwing in the knots. So you're going to negate the P and negate the Q. So if the opposite of an animal is a puppy would be the animal is not a puppy. If the animal is not a puppy, then it is not, so up here it says it is a dog, this one should say it is not a dog. And the third one, the contrapositive, is tilde Q, arrow tilde P. So here we switch the P and the Q and we negate both. So if it is not a dog, then the animal is not a puppy. If the animal is not a dog, then the animal is not a puppy. Now you may be asked to say whether these things are actually true or not. So let's look at the first one. If the animal is a puppy, then it is a dog. Well, so this one takes a little bit of knowledge of animals, but when I think of a puppy, I think of a baby dog. So my initial reaction would be that this is true, but if you know enough about animals, there are actually lots of animals that have that have babies called pups. Just to name a few, the seal, the shark, the fox, the rat, and that's just me doing a Google search. I don't typically know what baby rats are called, but in this case, there are puppies that are not dogs. There are pups who are baby sharks. So this would be false. The converse, if it is a dog, then the animal is a puppy. So are there dogs that are not puppies? Because this says if you own a dog, then it is a puppy. Are there people out there that own dogs that aren't puppies? Yes, there are. So not everybody with a dog has a puppy. That is a false statement. The inverse, if the animal is not a puppy, then it is not a dog. Do you think there's anyone at North Central that owns an animal that is not a puppy? And does that mean it is not a dog? This is also false, because somebody can own an animal that is not a puppy. Maybe they own an adult dog. Then it is not a dog. That's then not true. It is a dog, which makes this statement false. The next one, if it is not a dog, then the animal is not a puppy. This is false because there could be an animal that is not a dog, but could still be a pup, like the baby shark. It's not a dog, but it is a puppy, which makes the statement false. In order for the statement to be true, the first part has to be true, and the second part has to be true. Both must be true. So we're going to skip example 2 for right now. We're going to look at example 3. Decide whether the statements about the diagram, the statement is true, and then we don't particularly need to explain in any type of written language. We'll talk about how you know in this scenario. So here, LM bisects segment JK. So here's LM bisects JK. Remember, bisect means to cut or divide into two equal length pieces, two congruent pieces. By two congruent pieces. So does line segment LM cut JK into two equal pieces? That is true. And we know that, look right here, the congruent marks. JR, segment JR, is congruent to segment KR. And I'm going to write that out to help with the symbols. Segment JR is congruent to segment KR. Let's look at the next one. Angle JRP and angle PRL are complementary. Complementary means they add to 90 degrees. So JRP is this angle right here, that skinny one. PRL. PRL is this one right here. So do we know that those two angles add to 90 degrees? Well, they look like they add to 90 degrees. These lines look like they're perpendicular. But it's really important in life in general that we don't judge pictures or things or people off of how they look. We need to know the facts. We need to know the truth about this picture. And do we know that these lines are perpendicular? Do they say in words? Do the directions say that they're perpendicular? No. Does the symbol perpendicular, the 90-degree mark, this symbol, is that anywhere in this picture? So the fact that you think it looks 90 degrees, you're judging it based off of how it looks, and it may or may not actually be 90 degrees. There's no way for us to know. No way to know. They might be complementary, they might not. We don't know because it's not marked in the picture. Let's try the next one. Angle MRQ is congruent to PRL. So this one with two arrows is congruent to this one with two arrows. This is actually true. This is true. And the reason for this is, do you see what is in this picture? There's an X right here in the middle. Do you remember the vocab word for that? It was one of those from chapter 1 that's super, super important. Vertical angles. It's true. Vertical angles are congruent. And typically in math class, I use the symbol for congruent if I'm going to write it out. Now I need to include at least one more example, so I'm going to go back up here to example 2 and write a new problem. We are going to use a definition like perpendicular, two lines that intersect. Let's use a different one. Something like a triangle. A triangle is a polygon with 3 sides. That's the definition of a polygon, or of a triangle. It's a polygon with 3 sides. We're going to use this and create an if-then statement. So it's similar to here. If you look, this perpendicular definition, it always throws me off because it doesn't seem to belong. But if you actually read the vocab, the definition here, if two lines intersect to form a right angle, then they are perpendicular lines. Many of the definitions are if-then statements. What I want is for us to turn it into a biconditional. P, if and only if Q. So we need something that has an if and only if in the middle. I like to start with what we are defining. So what is this the definition of? It's the definition of a triangle. So I would say it is a triangle. Then goes the if and only if. If and only if right in the middle. And then what makes it be a triangle? It is a triangle if and only if it is a polygon with 3 sides. The words are coming from up here. It is a triangle if and only if it is a polygon with 3 sides. You need to be able to take definitions like this and write the biconditionals. So let's call that example 2. And then I'm going to give you one more example, example 4. I think this will help you with your homework. It is taking 2 if-thens, the original conditional and the converse, and making one biconditional out of the 2 sentences. So let's see here. Let's do these sentences. If I am hungry, then I will eat. Right? If you are hungry, then you will eat. If I am hungry, then I will eat. If I eat, then I am hungry. That is, if I am eating, then I am hungry. If I am hungry, then I will eat. It goes both ways. The hunger causes me to eat, but I am eating because I am hungry. And we can take these 2 sentences and turn it into one biconditional with if and only if in the middle. So, maybe whichever way sounds better to you, I eat if and only if I am hungry. If and only if goes in the middle. The P and the Q say I am hungry and I will eat are what go before and after the if and only if. It doesn't matter. You could also say I am hungry if and only if I eat. That works also. Either way is okay. You should now have enough to go ahead and do section 2.1.